Hey guys, welcome to my YouTube channel. So in this lecture, we are going to extend what we have understood in last class. So last class we came into a beautiful terminology called band. So now you guys will well know that what is meant by band, what is meant by energy level. So when the band will be formed, whenever there is an interaction of more number of atoms with together or some kind of interaction is coming into picture, this kind of bands will form, sorry. So now we are ultimately we are going to learn about semiconductor devices. So semiconductor device means we will be focusing mainly on silicon, right? So in this class we are going to see about the silicon structure. So silicon number of electrons will be 14. So which configuration can be written as 1s2, 2s2, 2p6 and 3s2, 3p2. So outermost shell there will be 4, means that is off filled. So that is a off filled means it is partially stable. So it is if it is fully stable, it is full means it is fully stable. If it is half full means it is partially stable. So we are going to draw here. So let's take that here. So 2 electrons will be here. It can be at any state. I am taking this as reference. So here in 2sp 2 electrons, and here there will be 6 electrons, 3, 4, 5 and 6. Okay, then in the 3 shell, third one S will be 2 and P also will be 2. Okay, so most of the time our region of attraction or where we will consider is the outer orbital. So why we are always focusing on outer orbital? If any idea, please drop in the comment section. So outer orbital. So why outer orbital is, there is another one name for the outer orbital is called valence shell. So this is one important term, valence band or even valence band. When many silicon atom come into picture, we will call it a valence band. Now it is for single atom, so we are using shell. So we have to use the terminologies very carefully when we are well versed in these kind of bands and energy level theory. So why we are focusing on outermost theory is that outermost energy shell is that the conduction purposes. So for conduction purposes. So conduction band is the band where the electron will jump to produce the electricity or movement of electron current. So conduction band. So outermost energy orbital, the electrons can be easily pumped outside. So electron made easily outside. Electrons made easily free. Because the force with the central nucleus will be less, because it is a far distance, right? So we can easily kick this electron outside. So for that purpose we will be focusing on the outermost orbital. Second one is that outermost orbital is more influenced by the nearby atom. So influence or attraction with other atom, attraction with other atoms. So this is the two thing. We will be mainly focusing on the outer orbital for many of the cases. So let's see the two outermost orbital alone. So that is 3p and 3s. So max filament, what possible is that in the p shell 6 electron can be filled at the max. So max states will be 6. Now filled state is 2. Filled state is 2. So 4 vacancies there. So empty states is 4. Then 3s max state is 2. Max states which is equal to 2. Filled state is 2. Empty is 0. So we are writing this because we are going to draw a band structure for silicon. So for that only we are making use of these data. So once we draw those atomic structure, you guys will be understanding more things. So 3p electrons energy will be more than 3s energy. Okay, so this is one state. We already know as the radius increases, the energy decreases, and here the statement of thing is different. How the thing is that it's a negatively influenced energy level. So P will be having the more energy state because the potential energy will increases when electron which is present at the outermost cell. So here we are going to draw a energy diagram. So we are taking two states of reference E, and this is same as distance, and this is same as the distance R, and this is E. So as usual, let's focus on outermost orbital, where this is 3p and where this is 3s. So both will be at the ordinary state whenever there is no interaction. Okay, so max filament, here the max state I am directly writing as mx, max state which is equal to 6n, and filled state fs which is equal to 2n, and empty state which is equal to 4n. Here everything is 2n, and the empty state which is equal to 0n. So which is max filled state which is equal to max state. Okay, so here this is 3p and this is 3s. So whenever there is interaction of different atoms come into picture, the band will be getting split like this. So like this it will split. So it will split like this. So here the lower orbital will also split, right? So this one will also came and join here. The band will join here. So this is how, depending upon the number of atoms coming into picture, it will separate. So there will be a state of separation like this. So if we map this together, the doctor line. So we are taking this uppermost state and this lowermost state here, and we are considering the gap between them, and we are drawing this lowermost state. Even it's coming down, right? So lowermost state is here for our reference. Okay. So here there will be huge bands will be there, like depending upon the discrete number of energy level, many kind of intermediate discrete bands will be there. So that is not our recommendation. So what we are going to draw here is the band structure, not the energy level state. So this entire thing, what we will call here is this is valence band. This is valence band or outermost shell. This will be the valence band. And here this will be called as the condension band. Here the movement of electron from this valence band to condension band will be responsible for the movement of electrons, and that will be responsible for the current production. Then this gap here it is called, this is the EG or energy gap or band gap. This is an important terminology. So how we now we came into know how the band gap is produced. This gap is there, right? So this is what the EG. Okay, so electron jumps from this 3s to 3p, then it will be responsible for producing the movement of current, and that movement of electron, that will be responsible for the production of current. So now you guys were able to understand this one, right? So this is how the splitting of silicon atom will happen, and the respective energy band production will take place. Okay, so I think this is very clear for you guys. So if you guys have this the upper band is this energy level. I'm not exactly pointed out, so that will make it. So the uppermost energy is this one, the lowermost energy here, this is here, and this is the band gap, and this one is the respective structure of valence band. I hope this give you a clear understanding. So if you guys have any doubt, please ping in the comment section. Thank you. Stay tuned for next lectures.